Welcome back. While passing a function to the target argument works well for simple tasks, the object-oriented approach is often cleaner for complex threads that need to maintain internal state or properties. This involves creating a custom class that extends the base threading.thread class. 1. Defining the custom thread class. To extend the class, we define class workerThread, inheriting from threading.thread. Crucially, we must override the special .run method. This .run method is the equivalent of the target function. When the thread starts, this is the method that executes. Any initialization, like setting the thread name or internal data, is done in the constructor, remembering to always call the parent's constructor using super.init parenthesis. 2. Instantiating and starting the class thread. To run the custom thread, the steps are familiar. First, instantiate the class just like any other Python object, passing any arguments defined in your custom constructor like the thread name and task count. Second, call the .start method on the instance. Just like with the function approach, the .start method is what triggers the operating system to begin concurrent execution of the thread's .run method. 3. The .start versus .run distinction. It is a critical distinction that you must always call .start not .run. Calling .start correctly registers the thread with the operating system and invokes .run in a separate, concurrent thread. If you mistakenly call .run directly, the code will execute, but it will run in the main thread, completely defeating the purpose of multithreading. To summarize, subclassing is the OOP way to create complex threads. Our next lecture 26.06, Thread Using a Class. See you there.